Experimental study on ground granulated blast furnace slag, GGBS, based polymer concrete using polyethylene terephthalate, PET, fibers as fine aggregate. Abstract: the present study investigates on polymer concrete with ground granulated blast furnace slag, GGBS, and polyethylene terephthalate, PET, bottle fibers. The polymer concrete is prepared with epoxy resin and aggregates. GGBS is added as cement replacement and aggregate is replaced in different percentages by PET bottle fibers, 0%, 5%, 10%, and 15%. The compressive strength, spilt tensile strength, and flexural strength are experimentally evaluated. The influence of PET bottle fibers on workability, compressive strength, split tensile strength, and flexural strength are discussed and compared with a conventional concrete. Keywords: polymer concrete, GGBS, PET bottle fibers, epoxy resin, mechanical properties. 1. Introduction. Concrete is a composite material composed of fine and coarse aggregate bonded together with a fluid cement paste, that hardens over a time. Compared to cement-based concrete, polymer concrete is more stronger and durable. For this reason, polymer concrete is used in many structures such as box culverts, hazardous waste containers, trench lines, floor drains, and in the repair and overlay of damaged cement concrete surfaces including pavement and bridges. Despite its advantages, however, polymer concrete is not used widely due to its relatively high material cost compared to cement-based concrete. 1. Polymer concrete increases the strength characteristics as well as resistance to environmental factors. 2. Enhancement of the properties of polymer composites is a complex problem, due to the different optimum condition for the setting of both CO binders such as cement hydration and hardening of the organic binder. 3. To utilize the wastes and to protect natural resources, aggregate can be replaced partially by silica fume, recycled glass, fly ash, GGBS, polystyrene granules, sawdust, PET particle, etc. 4. In this paper, we are presenting the experimental results obtained on polymer concrete with PET bottle fibers waste used as substitution of aggregates. The effects on workability, compressive strength, spilt tensile strength and flexural strength are investigated by testing different mixes in which dosages of cement by ground granulated blast furnace slag, GGBS, and fine aggregate replaced by PET bottle fibers. 2. Literature survey. Semi-Hate et al., 2010, have investigated the utilization of shredded waste polyethylene terephthalate, PET, bottle granules as a lightweight aggregate in mortar. The water absorption values of the mortars produced in this investigation were within the limits of the lightweight concrete absorption value. The shrinkage values of the mortars containing PET aggregates were higher than the shrinkage values of the mortars containing PET and sand aggregates. The use of shredded waste PET granules and GBFS in mortar would be helpful for the environmental concern. 5. K. Ramadevi et al., 2012, have discussed an environmental issue as waste plastic bottles are difficult to biodegrade and involves processes either to recycle or reuse, that is, way it used in the concrete field. The concrete with PET fibers reduce the weight of concrete, and thus if mortar with plastic fibers can be made into lightweight concrete based on unit weight. 6. S. Aravalagan, 2014, studied the concrete with GGBS as a replacement material in cement with increasing demand and consumption of cement. Researchers and scientists are in search of developing alternate binders that are eco-friendly and contributes towards waste management. Use of industrial waste products saves the environment and conserves natural resources. It is observed that GGBS-based concretes have achieved an increase in strength for 20% replacement of cement at the age of 28 days. Increasing strength is due to filler effect of GGBS. 7. D. Farooq et al., 2017, the ground granulated blast furnace slag is pozzolanic materials that can be utilized to produce highly durable concrete composites. Ground granulated blast furnace slag is known to produce a high-strength concrete and is used in 2 different ways as a cement replacement, in order to reduce the cement content. 8. 3. Materials proportion ratio and mixing procedure. An experimental program has been carried out for investigating the mechanical properties of polymer concrete 9. The polymer is prepared by keeping 20% GGBS as replacement of cement and the requisite quantity of PET bottle fibers, viz. 0, 5, 10, and 15% as replacement of fine aggregate by mass. The tests performed in hardened state are compressive strength, flexural strength, and split tensile strength, also determining the influence of PET bottle fibers on workability of fresh prepared polymer concrete are studied. In the present study, 4.75 mm down the size of river sand as fine aggregate and 20 mm down size aggregate consider as coarse aggregate. The tests are conducted as per IS. 2386 to 1963. The molds used for casting the specimens are selected as per IS. 516-1959. The cube molds of size of 100 mm x 100 mm x 100 mm are used for the compressive strength test. Cylinder molds of size 100 mm diameter and 200 mm height are used for split tensile strength test. And beam molds of size 100 mm x 100 mm x 500 mm are used for flexural strength test. For each concrete mix 6 cubes, 6 cylinders and 6 prisms have been cast and tested. 3.1 Materials estimation. The mix design is carried out for M30 grade concrete according to IS. 10262 to 2019. In this study the GGBS is added as weight fraction of 20% by weight of cement, keeping 20% GGBS constant for all mixes, and PET fibers are added as weight fractions of 0%, 5%, 10%, 15% by weight of fine aggregate. The water-cement ratio is kept as 0.43 and epoxy resin used as 3% of weight of cement. 3.2 Slump test. Concrete slump test is a measure of determining the workability of concrete mix prepared in the laboratory or at the construction site during the progress of construction work as shown Fig. 2. The slump test is carried out as per IS. 1199 to 1959. Slump values are given below in Table 7. For results and discussion. The results of experiment tests on the hardened polymer concrete are presented here. 4.1 Compressive strength. The highest value of compressive strength 41.28 MPa is obtained for mix M3, and the minimum value of compressive strength 32.62 MPa is obtained for M5. 4.2 Spilt tensile strength. The highest value of spilt tensile strength 3.17 MPa is obtained for mix of M3, and the minimum value of compressive strength 3.65 MPa is obtained for M5. 4.3 Flexural strength. The highest value of flexural strength 11.32 MPa was obtained for mix of M3, and the minimum value of compressive strength 10.15 MPa is obtained for M5. 5. Conclusions. The results of experimental study on ground granulated blast furnace slag-based polymer concrete using polyethylene terephthalate bottle fibers as fine aggregate have been discussed. This investigation contains an experimental observation in which the comparison between conventional concrete and polymer-based concrete has made. In the present study, it is observed that the strength properties such as compression, spilt tensile and flexural strength are increasing up to 5% PET fibers replacement for M3 type of mixed polymer concrete.